Hi grade 10s. Today we're going to estimate area using grids. So to do that, we are going to look at some irregular shapes and try to figure out their areas. Now, when we do this, probably the best way of looking at this is thinking to ourselves, how many complete squares are shaded and how many partial squares are shaded. So let's take a look at this triangle that we have here, and let's try and see if we can figure out how many complete squares are shaded. So let's mark off complete squares. There's one here, 2, 3, 4, 5, and 6. So there are complete. How you spell complete? That's how you spell complete. There's 6 here. Now let's look for halves. I know for sure this is a half square, this is a half square, this is a half square, and this is a half square because I could see the way it's shaded. So I know I have two halves for sure. All right, I know I have two halves. So, or rather two whole squares from four halves. So I know I could put 2 there from those ones. Now I'm left with, I'm going to highlight it here. I'm left with basically this side of the triangle. And for us to find out the area of that side of the triangle, well, here's what I can see. I can see that these 3 pieces probably add up to one whole, and these 2 pieces probably add up to another whole. So I get another 2, which makes an area of 10 grid squares. Okay? And we knew for sure the 6, that was pretty easy to count. But then we had to group together some partial squares to come up with the last little bits to add up to a total of 10 grid squares. Okay? We have to show our work when we do this. If you give me just a number, that's not enough. You've got to show me what your thinking was. Okay? Coming up next, we have making sure yeah. On the grid below, 1 square represents 1 centimeter squared. What's the approximate area? So again, what we're going to do is count the number of complete squares. So here's a complete square, here's a complete square, here's a complete square, and there's a complete square. So we know we have 4 complete squares for sure. Okay, there's 4 complete squares. Now, we have to see what else we have here. So to figure out what else we have here, what I could say is that this one here and this one here are close to being full. Close to being full. And maybe all they need is this one here to fill them both up. So with those 3 pieces, it adds up to give me 1, or rather 2. With these 3 pieces, it adds up to give me 2, so that's 4 more. Another 4 more, and another 4, or another 2 more. Rather, sorry, I've got to just bear with me here. I'm going to correct myself here. This gives me 2, this gives me 2, this gives me 2, and this gives me 2, for a total of 8 partial squares. So partial, I have 8, for a total of 12, and because we're told that 1 square is 1 centimeter squared, for a total of 12 centimeters squared in area. Okay? All right, So you have to do something to show your work when you're doing these questions. If you just give me a number, it's not good enough. One more question. Here we are. This is like an irregular shape. 1 square represents 1 square kilometer. What's the approximate area of the lake? So what we'll need to do then is just mark this off as 1, 1, 2. Wow, these are all completes. So I definitely have 6 complete squares shaded. Then we have to figure out what we have to do to make holes. Well, if I took something like this one here and added it to this one here, that would make a partial. That's 1 partial. So I'm just going to put 1 over here. If I went and added, say, this one here with this one up here, that'd be another partial. And I'm just going to put a 1 beside it, like again, ticking, I'm counting. If we were to go and add, say, this one up here with this one down here, that would be another one. If we were to add these two together here, that would be another one. And if we were to add this last piece here, all of these pieces here, and these two here, then that would probably give us 2 more squares. So that gives us a total of about 6 partial squares. And again, it's an estimate. So altogether, we have an area of 12 square kilometers. Counting up the number of complete squares is very straightforward. Coming up with combinations of partial squares so that you get complete squares is what will take you some time. There is a homework assignment for this, and I want you to complete it. It is for marks, and I will see you next class.